Sorry, I just want to kind of scare you. So, all right, let's do some examples using and applying the altitude on hypotenuse theorem, but really just part B. Remember, part B is just really strictly focusing and honing in on the altitude and how that kind of plays into when it's drawn to the hypotenuse of a right triangle. So let's do an example. Actually, I think I have 4 examples here, so we'll fly through these now. You can look at the wording of part B, but it says this. If you have an altitude drawn to the hypotenuse of a right triangle, then that altitude length, and that in this case, what we're looking at, this one right here is what we're trying to find, the altitude. So ladies and gentlemen, that means then that altitude is the mean proportional. The altitude length, the length of the altitude, is the mean proportional between the 2 individual segments of the hypotenuse. And remember, this whole thing right here from B to A, BA, that is the entire hypotenuse. So the individual pieces of the hypotenuse happens to be BD, and the other one happens to be DA. So DA is going to go right there, the length of DA, whatever that is, and the length of BD is going to go right there. So again, that theorem, go back and look at the wording, but that's how it works. Wonderful. So I will put 16 right here. That's one of the individual pieces of the overall hypotenuse. 10 is the other one, the other length of the little piece of the overall hypotenuse. And then, of course, I just solved this by doing means extremes product theorem. So I get x squared equals 160. And remember, then you would take the square root of both sides. Do you remember what happens when you take the square root of both sides? I do. It is plus or minus. That's right. So we'll take this 160, as we just talked about in section 1. We need to simplify that. So think of the biggest perfect square that goes into 160, which is 16. So the square root of 16 and the square root of 10 is what that guy would break up into. So that means this thing is a perfect square. Therefore, it comes out of jail, price to be paid. So that goes to just a 4. And then this 10 is not a perfect square, so it has to stay in jail. So it is square root of 10. Now here's a scoop, guys. You have plus or minus still, don't forget that. So technically, the answer to this equation is x is either positive 4 root 10 or it's negative 4 root 10. However, you're going to see this in all the examples that we do. We're talking about finding the length of the side of a triangle. So that means then that really this thing right here, the negative, that doesn't make any sense because you cannot have a negative length for a side of a triangle. So technically, we just disregard that answer. So the answer is really just a positive 4 root 10. You're going to see that throughout the other examples too. We're finding the length of the side of a triangle. So even though I want to make sure you remember it's plus or minus when you do the square root of both sides up here, but we're disregarding the negative because we don't need that one because we're talking about, again, the side of a triangle. So there's that one. 4 root 10. Let's move on. Similar question. You got the altitude drawn to the hypotenuse of a right triangle. What we are trying to find in this one is the length of the altitude. So, ladies and gentlemen, the theorem says exactly that. That means the altitude length is the mean proportional. That's how you start them all. The altitude length is the mean proportional between the 2 individual pieces of the hypotenuse. BD happens to be one of the individual pieces. DA happens to be the other piece. Problem. I don't know the length of DA. But I do know the overall length of the entire hypotenuse, and simple subtraction, of course, would kind of give you exactly what this little piece is. That will be a 6. Woo! So there we go. So we got 10 is the one piece that goes up here. 10 goes right there. And then 6 is the other piece, so that 6 goes right here. And there you go. So that is your proportion. Solve it up, you get x squared equals 60. Take the square root of both sides, so it's going to be x equals plus or minus, positive or negative, but disregard the negative. So it's the square root, positive square root of 60. So we got to break up its 60 into 2 things where one's a perfect square. Find the biggest one. The biggest one happens to be 4. So the square root of 4 and the square root of 15 is what this guy breaks up into, those 2 individual radicals. So therefore, that guy right there, square root of 4, comes out of jail and goes to a 2. 15 is not a perfect square, so it just stays 15. And ladies and gentlemen, congratulations. There is the length of that particular altitude right there. It's 2 root 15. So there's 2 of them. Now let me change this examples up a little bit on you. Uh-oh. Check this out. Well, it's still the same thing in terms of the picture. We have an overall right triangle in that of HAM, good old triangle ham, right triangle ham. We have this altitude drawn to the hypotenuse. This whole thing right here is the entire length of the hypotenuse. I am given, however, the length of the altitude. Ladies and gentlemen, the theorem doesn't change. It says if I have an altitude drawn to the hypotenuse of a right triangle, then the altitude length, oh, check this out, is the mean proportional, so I happen to put 16 and 16 in for that in the means, because that's the altitude length. Now, keep going. It's the mean proportional between the individual pieces of the entire hypotenuse, so HS and SA. So, let's put them in there. 8 is one of them. That guy goes right up here. And the other individual piece, oh, I don't know. That's what I'm trying to find. So that happens to be X. So there you go. That's perfect. So we do means extremes product theorem, which means we get 8x. Lovely. 16 times 16 gives me 256. Ooh, this is nice. Notice, I don't have any x squareds here, so I'm not going to get a plus or a minus. I would just simply divide both sides by 8, divide this side by 8, and that side by 8, and I get my wonderful answer for that individual piece from A to S, that guy right there. 256 divided by 8 gives me 32, I do believe. So there is your final answer for what we are trying to find right there. So there you go, a little bit of a different example. So let's do one more. This is going to be a trickier one because you're going to see, oh, now I have a radical as one of my side lengths for the altitude. Ladies and gentlemen, guys, girls, it doesn't matter. You still set it up exactly the same way, because this now is given to you as your altitude length. So wonderful. That means in my proportion, 2 root 3 is going to go right here, and 2 root 3 is going to go right there. I don't care how ugly, how pretty, if it's a number, if it's a letter. The altitude length always goes in as the means, because that's what the theorem says. The altitude is the mean proportional between the individual pieces of the overall hypotenuse. And by the way, back to that, this piece S to A, that's one little individual piece of the hypotenuse. The other piece is what we're trying to find, HS. Lovely. So let's set that up. Let's say 5 is the one piece that goes up here as the extreme. And then this one right here, I don't know what it is. Let's let it be X. Wonderful. A little bit trickier in this regard because now you're looking at the same thing as all the other three, means extremes product theorem. That gives you right here, 5x. I'm going to write this next one out so you can see it. And then when I, whoa, that's weird. Erase that a little bit. There we go. So then when I multiply this guy, 2 root 3 times 2 root 3, I'm going to write that out. I'd recommend you doing this too, writing in parentheses. It's 2 root 3 times 2 root 3. Like that. So, why did I write it out that way? Because if you remember my jail analogy back from section 1, now you can take these things that are outside of jail and you can multiply those together and get 4. You can take the things that's inside of jail, which is the root 3 and the root 3, multiply them together and get the square root of 9. By the way, that still equals this 5x. We're not done yet. So now I just keep on simplifying. 4 times the square root of 9 is the same thing as just a 3 because the square root of 9 is a 3. Lovely. So if I keep on rocking, you're going to see the answer. I'm going to get 12 here. Divide that by 5. It means x is going to be an awesome answer of 12 over 5. Now if it asks you to do a decimal, you could obviously do that as a decimal. It would be just 2.4. So there you go, guys. 4 simple examples, quick examples of how we actually use this altitude on hypotenuse theorem to find different side lengths. So we're going to practice this, of course, a ton in class, and we're going to master it. And we're going to lead to part C of this particular theorem and roll with that. You guys are awesome. We'll see you later. Have a great one. Bye.